Good evening, everyone. A warm welcome to the day two of the OlympAI Hackathon Grand Final. Starting with the grade 9 to 10 category, we are excited to have all of you here today. And we truly appreciate the creativity and hard work shown by every team. This is a 1 hour showcase, and we will run on a tight schedule. Please note there will be no result announcement during the session. We will close with a short feedback segment from the judges. Let's begin. Today, we are honored to have two distinguished experts as our judges. It is my pleasure to introduce them Dr. Sachin Gupta, Dean, Research and Innovation, MAIT Delhi. Dr. Sachin Gupta brings over 21 years of experience in academia and professional world. He has held leadership roles such as Dean, HOD, and Director at various reputed institutions. His expertise lies in artificial intelligence, machine learning, and he guides scholars working on predictive ML models for engineering and business analytics. He contributes to national accreditation bodies including NBA, NAAC, and NIRF, and is a life member of CSI and ISTE. Dr. Gupta has published extensively and authored multiple books on AI and data science for CBSE students. Recently, he was honored with an award for outstanding contribution to AI literature by AICRE. We are privileged to have him with us today.
Thank you, ma'am.
Hello, sir. Our next judge, ma'am, Dr. Bhumi Gupta, Head Information Technology and Engineering Department, MAIT Delhi. Dr. Bhumi Gupta has over 20 years of experience in engineering, education, research, and academic leadership. She heads the IT and Engineering Department at MAIT and is deeply involved in curriculum enhancement and faculty development. Her research interests include artificial intelligence, machine learning, and natural language processing. She guides PhD and postgraduate scholars and is a member of professional bodies such as CSI. Dr. Gupta has numerous national and international publications and frequently organizes academic events including conferences, seminars, and FDPs. We are delighted to have her with us today. Hello, ma'am.
Hello, ma'am. Thank you for the invite.
My pleasure, ma'am. Now, here are some instructions to the team. Before we begin, here are some presentation guidelines. Each team gets 6.5 minutes in total, 3 minutes for presentation and demo, 4 to 5 minutes for Q&A. Judges may interrupt briefly for clarification. Please ensure your microphone, camera, and screen sharing are ready before you turn. With that, let's proceed. We now begin presentation for category 9 and 10. We have 7 teams presenting their innovative projects. Sorry. Each team will get approximately 6 minutes to present, followed by a short questionnaire. So here, I welcome the team Catalyst. Your time starts now. I request teams to showcase their projects directly, and then we can come back to presentation if needed. Please show us your project.
Team The Catalyst, are you there?
Sorry, sir. Good evening, respected judges and my fellow participants. We, the Catalysts, are going to begin with something most of us often overlook: a farmer losing his weeks of efforts just because the plant disease was not detected early enough. And that is exactly where our app AgroLens stands. Our app is run on command prompt. Our first step was to design the front end of our app, which is made with Streamlit, a user friendly interface where anyone can upload a leaf image and instantly see the disease prediction and cure. It makes the app feel like a simple website, even though complex AI runs behind it.
In the backend, all the main processing happens. The image is opened and resized using PIL, converted into arrays with NumPy, and then features are extracted using color histograms. These features are passed into the machine learning model, which we have trained using random forest classifier. We chose random forest classifier because it is fast, accurate on small data sets, and does not require heavy hardware. The model is stored using Pickle. A cure dictionary in the backend also ensures that every predicted disease comes with an instant treatment suggestion. Altogether, the software tools, Streamlit for UI, PIL and NumPy for processing, Orange for ML, and model support work like a smooth pipeline. They turn a simple image upload into a full diagnosis with a cure, making the app practical, easy to use, and genuinely helpful for farmers, students, and plant enthusiasts. Thank you.
Have you used Orange for ML in your project?
Yes, sir.
Team, I
Please
would
speak a little
request you
louder.
to switch on the video. Judges, you may continue with the questions, please.
Hi, Ananya, Kritika, Avni. Have you used Orange ML, Orange data mining in your project?
Yes, sir. We use it to train the model using images of plant diseases.
My question was different because when you mentioned Orange, it would have been something different. I was looking forward for you to tell me a way to how to export a machine learning model from Orange.
Actually, sir, when we coded the app, we used command prompt to code it uh, on like code it locally. So when we coded the app, we added to upload the trained model in the app directly when we access it. That's why we just added the PKL file in the app, and it trained and loaded the model successfully, which help us execute the model.
How did you create the pickle file?
Um,
On orange determining.
Okay, more
So we
questions.
first trained our model in Orange, and then there was a widget which was of Save model, which was present there. Then we connected our model from the Save model icon, and then we browsed to choose our location. And then we saved a pickle PKL file from which our app is connected.
Okay. Can you show me the code where you are actually uh, importing the pickle file?
Yes, sir. This is the code.
Can't see. I'm just looking at your screen presentation for AgroLens still.
Team, please hurry up.
Can you show me your orange workflow also? Can I see the orange workflow?
Team, we don't have much time. I have to proceed with the
Yeah.
next team if you're not able to showcase right now.
Okay. All right. Thank you. Bhumi, if you have any question, please.
No questions.
Thank you.
Okay, team, thank you so much. Now we will move to the next team. I invite the team Genius Duo to present. Your time starts now. You can stop presenting. Thank you. Team, the Genius Duo can present now.
Just a second, ma'am.
Sure.
Is my screen visible?
Team, please proceed with the project. We can come back later on presentation if needed. Please show us your project.
Actually, ma'am, we have a problem right now, and we can't show the live like model. We can show the coding behind that and the result screenshots and the training history screenshots.
No problem. Please show. The judges are here.
Okay. So these are screenshots. This image was the. This will be the results, and this will how the code will look when the prediction is complete. And this was the orange workflow. And this is the model accuracy data which was shown when I trained the model. And after the training was complete, this was shown, and this shows how much accuracy the model can achieve.
You don't have your orange flow also?
This is
Please
the
switch on your
orange
video
workflow,
as
sir.
well. We can't
Actually,
see.
my camera isn't working. Ryan's camera is working. Ryan, can you switch on your camera?
Okay. No problem.
Yeah,
Okay,
I'm
so
trying.
should I start with my speech?
Yeah, can I have the blow up of your orange?
Sure, sir.
I mean, it's very small for me to see.
Just a second, sir. Sir, can you see this?
Okay, now walk me through it.
Okay, so like we import the images here, and
This is
the
already,
project does.
you have it open. Can I see it running?
So this is how like the in this we can't do it right now because like we have majorly used command prompt and the Python actually we have used the Python for running.
Hey, but the students need to show it running.
But
So ma'am, right now like from my computer I was the one who like planned to run, but actually my computer, the old computer was I'm not able to retrieve it because some family problems. And like my new laptop has the codes and all everything, the workflow and everything, but it doesn't have the trained model like the .h5 and .keras model, so it can't run right now.
relax, relax. You don't require a trained model in this. For orange, you just need to import the images and it should run.
um so let me try, I guess. Um, Ryan, do you have the images in your computer right now?
Yeah. Let me send it to you.
Team, you have 2 more minutes.
Okay. In the meanwhile, they do it. What did you use Keras for?
But actually, the like when we use Keras, we use to improve the performance of the, uh, the model, the overall performance of the model, and it enhances the model a lot, and it like collaborates with TensorFlow, which we use 2.12 version, and the overall model is very good because of it. Because Keras like is a tool that helps us build machine learning models easily. So we can just
What I am sensing, Mira, is that there are two things that you are talking about. One is the orange model, which you are showing, and another one is a completely different project working on deep learning, which is not associated with the orange in any way. Am I correct?
so I would say partially correct, sir. Like we used like command prompt. We never used orange to calculate the results. We could have shown the results right now, but actually my old computer is not working, so I couldn't show. I can give you the speech and I can tell you the codes and I can show you the codes. But right now, due to some unfortunate family problems, I can't retrieve my old laptop.
Okay. I hope that file is sent ready, or we can come back to you.
Sir, may you repeat?
Yeah. Radha ma'am, we can take them back after. Let them sort the uh, data
Sure, sir.
thing.
Yeah,
Yeah.
I think we
Sure,
should
sir.
move to team three now because
Yes.
Yes.
that was their problem that they couldn't get the code now.
Right, right, ma'am. So thank you, team. You can stop presenting. We now invite Team Karen Barrier, Breakers to present. Your time starts now.
Yeah.
Good afternoon, sir. Good afternoon, ma'am. Am I audible?
Yes,
Yes, you
audible.
are. Please switch on your camera as well.
Yes, sir. I think my screen sharing is visible.
Yeah. Go on.
Yes, sir. So my project name is Falcon, which means fake article. One second, sir. Yes, sir. So the project name is Falcon AI, which means fake article locator and credibility observation network. So let me not waste time and bring it to the working with. Here, what this does is that we can predict whether an article is fake or real using logistic regression. So I have brought two articles here. One is a real article and one is an article with fake news. So let me try putting into it and checking, predicting it why it is real and fake. So this has predicted that the article is real and the actual article is also real. And what is the specialty in this project is that it explains why it is actually real using line. So here a few words are actually highlighted saying why it is real and why it is fake. And it gives an overall prediction whether it is real or fake. So here's the source code. Here are the imports and other codes functions as well.
Can you show us the TF-IDF slider? And how does it work?
Yes, sir. So here's the TF-IDF slider.
What is the purpose?
TF-IDF means term frequency and inverse document frequency. This method is used to suppose if there is a document, we can know the importance of each word. So we are clearing the data set and we are trying to know which words actually repeat and which words don't in each article, so that we can know we can vectorize the words based on its rarity.
Got it. Dr. Bhumi?
Can I know how much data did you test it on? How many articles?
About 14,400 articles, ma'am. Here we can see the test samples.
And what is the accuracy?
Accuracy is about
96.2.
96.2%.
Okay. Okay.
You did it alone or you have a team member?
No, I did it alone, sir.
Can you host it on Streamlit officially, I mean on the cloud?
Yes, sir, it is running on Streamlit.
No, this is running on local host.
Yes, sir, it is like running on local host.
Okay. All right.
Yes, sir.
Thank you.
Thank you.
Thank you, team. Let's proceed to the next team now. You can stop presenting. We now invite team project Omicron to present. Your time starts now.
Ma'am, it's not allowing me to start my camera.
Yes?
Ma'am, I'm not able to start my camera. It's not allowing me. Disabled by host.
No, I think it's not. Please ask for the permission. We can allow.
Asked, ma'am. I've clicked on OK.
Okay, please proceed.
No, just like this one. Sure. Good evening, judges. Today we, Project Omicron, are going to be presenting our solution to a huge problem in the agricultural industry. The problem of plant diseases. 3 trillion kilograms. That's the amount of food wasted every year due to plant diseases. Our model. Yes.
Our model over here uses a lot of data which we have taken over multiple sources to make predictions on which disease it is and how to mitigate it effectively. So over here, our precision agricultural assistant has a front end in which we have options such as drag and drop, browse files, or use camera. We have further images such as personalized recommendations based on location. Our image pre-processing controls use formats which make the images into readable formats. So for example, if I quickly just upload an image over here, for example, apple cedar rust, the image analyzes the image, the model analyzes the image and tells you what is happening. So we use a complex system over here of 17 layers of inverted residual blocks, depth-wise separation convolutions, using logics like softmax and argmax. So as you can see over here, it did detect this. It is saying it is giving an accuracy of 91.0%. Now let us try to do this again, but with locations, right? So if I just quickly press analyze and I press my location as, for example, Delhi, right? So again, if I browse files and I put, for example, this one again. Right, so it will give me weather-based risk analysis for what is wrong and what can be done. For example, we have here the average temperature of Delhi, humidity, and the rainfall which has happened here. So we have an API running which takes in all the data from it, and then it tells you what is the average temperature, of course, and then what can be done. For example, over here it is saying it is favorable for fungal growth, and we should consider fungicides. Right. So over here, you can see that the front end is running from JSON. So we have the codes running in our processes here, and it's running from JSON. So all these codes are running like that. So yeah.
Brother, is this dummy data or is it actual?
It is actual data. I can show it to you. We did not use orange though because we thought it limited our process, complete process.
Question is different because you are not connected to the internet in your application, right?
Yes, sir.
And
So
you are
how
running
it's
it on a local host. How is it actually doing an inference connecting to the weather board?
Sir, so I understand your question here. So what we've done is we've trained a model, we've trained PyTorch to basically look through all of this data, and then when we host it over an actual internet, it will still run. So our entire point here was that most farmers live in remote locations where internet access might not be that stable. So we wanted to create a system where, well, it can run over the internet, but we wanted a system where when you download the app, you get a system where all of this data comes to you on your phone. So you don't need the internet to run that quickly. We want to make this as launchable as possible.
I got your point. My only question was that humidity for the matter. When you are saying high humidity, this would be variable day by day. Every day there would be different value of humidity, temperature, all the parameters which affect. So how is it going to be accurate for them if it is running offline?
So
It's
the
going to
thing,
be, it's a
So the
daily
weather
thing.
feature wouldn't be working if it was running offline because it needs the it needs internet data when accessing such information.
so the entire point here was that we kept location as an optional feature, which can be added on to give better results. That would of course require internet. But then all our models, PyTorch, everything that's running over there, that's running offline.
Okay, that means there is some part which is hybrid, something online,
Yes, exactly.
Yes,
Exactly.
sir.
online,
Like
something else
hybrid.
offline. Okay, Dr. Bhumi, your question?
But if it is not running on real-time data and it is not fetching it, how can you prove the accuracy is high?
Ma'am, I did
The
not understand
data
it.
for the model that we've trained is real data. We've taken it from Kaggle's Plant Village source. But the weather API, Yash could tell you more about where he is fetched it from. That
Yes.
is a sort of optional add-on. So
Right.
even though that data is real, it is taken on spot if the person has he has access to the internet.
That is right. But do you know the name of the project you have worked on is Precision Agriculture Assistant? The word precision is there.
Ma'am.
Okay, thank you.
Thank you, ma'am.
Thank you.
Thank you so much, team. We now invite Team Terranova to present. Your time starts now. You can share your screen and switch on your camera.
Warm goodwill to the esteemed jury and fellow participants. Today, I, Adya Sharma,
I, Krishank Jain,
and my fellow teammates Krishank Jain and Anshul Singhal, the three young coders powering the team Terra Nova, proudly present our project TruthLens AI. So, in the modern era, misinformation is becoming a rather trivial problem, and to solve this problem, we have come up with a solution and a app. TruthLens AI. So here is our user interface coded on GitHub and deployed on Streamlit.
so here's our user interface. So as you can see that here's the home screen. There are total of 3 screens in our UI: home, analyze, headline, and history insights. Here on the home screen, you get the info, how to use the app, and you can also get some frequently asked questions. Once you are ready, we can directly click on the button, go to analyze headline, and it will direct you to the main screen of our app, which is which will assess the news. Like if our news is new parallel portals have been opened by the government, and we have entered we have given the user to input their gender and platform where they have found the news, because in future we are planning to add the graphs of the most misleading platform, which is spreading all the fake news. So we just now click on analyze news, and the result will come, and it has been predicted fake because this news is not real. uh, Same for if we now test any real news like Red Fort was attacked by terrorists, like we recently know that it was attacked. So if we analyze it, the prediction will come out to be real. And if you have any thoughts on a project, you can just enter here and submit the feedback. And the last screen comes to be the history and insights. Here you can see all the history and insights. You have the all the the news headlines you have searched for on our app. So, but the real question is, what all made it happen? So the thing was this backend on GitHub. These are all the files which we have used. The main.py contain all our code, including the UI, and importing our model, configuring it with our UI code. All the code has been integrated in this one file. Our model Truthlands AI.pkl has been exported from Orange Data Mining with the text mining add-on, which has been very useful to us. We have also added the requirements.txt, in which we have used all stated all the uh, libraries that we have used. Yes, sir.
See the orange flow?
Yes, sir. Sure. Adya, please share.
I hope you can see my screen.
Yeah.
So here's the orange flow. So if you want, we can also show you live happening it in the orange itself.
Okay. Yes, please.
Adya predictions. So we have uploaded our test training data in the file, which you can see in the upper flow of orange. Uh, in uh, in the another flow which we were showing that we are loading our model, it will show you the predictions that have been done. We have imported the different CSV file for that flow. At their screen different predictions orange. Right. So, sir, here are the predictions. These are all different headlines from our training data CSV.
Okay. Can you explain the role of each of you in the work? Krishang, Anshul, Adya?
So, I did the backend coding, all the linking the model to the our UI model. UI was done by Adya, and the PPT and our help in coding was handled by Anshul.
Anshul, what do you think about the project?
Sir, basically the project is to analyze the news headline. You just need to enter the headline there, and then you will click the analyze news button, and it will show the
Adya,
result
what
as
can we
fake
do
or
better?
real.
Okay, Adya, what can we do better?
So, I think right now we are not fetching live data. Later in the future, maybe we can program it to fetch live data and update it daily. Right now, it's more of a prototype so that it works but does not fetch fresh headlines. Later, we can program it so.
All right, close your presentation. Thank you so much.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you so much, team. Now we invite Team Bhavan, Team 2 to present. Your time starts now.
Good afternoon. We are Bhavan Team 2. Today, I, Yashika, and my teammate Aditi will show you AgroDetect, our AI project that helps farmers quickly detect tomato leaf diseases and get clear next steps.
Small scale farmers lose a lot of yield because crop diseases go undetected or are treated too late. Our objective was to build a prototype vision model for tomatoes that identifies four common diseases and healthy leaves, gives a diagnosis and actionable advice. So we also have a language changing feature which supports local languages such as Hindi and Punjabi. So I can select the language from the drop down arrow and it changes the language of the interface. For now, I'll choose English and I'll upload the file. For example, I upload the image of this leaf and the prediction will show in a few seconds. So the disease is late blight or wet condition disease, and the recommended action is remove and destroy heavily infected leaves or plants, avoid wet foliage, water at the base only, and inspect nearby plants often and act early.
What's your training data?
So the training data was from Kaggle.
What was the size? Can I see the training data if it's on your machine?
So this was the training data we used, and we used Orange for training the model. So we imported the images and used image embedding for extracting the features.
Can we see the orange flow?
Sir, is the orange workflow visible?
No, not now. Not right now. I can just see your agro detect screen.
So let me share my screen again. Sir, is it visible now? Visible.
Yeah. What were the classes of the images which you imported? Can I see what is the images set that you have imported here?
So the classes we imported were healthy, early blight, late blight, septoria leaf spot, and yellow leaf curl. These were four diseases and a healthy class of leaves.
Can I see the confusion matrix?
So this is the confusion matrix.
Yeah, please open.
Aditi, yours in your screen, we can only see the workflow. Maybe you can share your entire screen and then any window that you open will be visible.
Oh, wait, hold on.
Better.
Can you explain me any of the column? Any of the column?
So this confusion matrix shows that the model often confuses early blight and late blight. Like here we can see the images as which were early blight. The model actually predicted late blight 140 times, and in late blight we can also see that it predicted early blight. So these were the most classes which the model confused. Otherwise, the predictions were mostly correct.
Okay. Go.
So this is also the accuracy scores of the model, which were all above 90.
All right. Dr. Bhumi, if you have any question.
Team members, what are their contributions?
Ma'am, I contributed in making the orange model. Yashika contributed in data augmentation, and we shared the work of data collection. And Yashika also helped in the PPT.
Okay.
Okay, all right.
Thank you so much, team. We now invite Team Shadow AI to present. Please switch on your camera and start presenting. Your time starts now.
Hello, am I audible?
Yeah, please go ahead.
Yes, Shaurya, you're audible. Please turn on your camera.
Sir, it is disabled by the host. I cannot turn on.
Please try again and then we'll allow you.
Okay. Yes,
Please
sir.
go ahead.
Yes, sir.
Yes.
Sir, I have created a small module with Raspberry Pi and camera module, and it is made trained with TensorFlow and data. It is a small module used that can be used in farms and homes, and it transfers the images that get processed into the websites, into this website, and when the image get transferred to the website, it identifies that what can be the disease in it, what can be the cure of that, and what can be the prevention that we can take to cure the disease. Let me give you a small overlook of that. And when we click on capture and analyze, we can select tomato and we can move to kitchen mode, in which I will take a tomato. And when I click on capture and analyze, it will take an image from the Raspberry Pi, and which it will analyze it and says that how much it is fresh and if there is a treatment
Result,
needed.
fresh. Confidence 55.6%. Advice, fresh and safe. Low confidence, please retake photo. Treatment, no action needed. Safe to consume. Prevention, store properly in cool, dry place. Use within recommended time. Check regularly for spoilage.
Hello. Yes, sir. And it speaks the output also. Let me show you the language we have four language currently workings that are English, Hindi, Spanish, and French. It speaks and you can have a full control on it, how much confidence threshold it should have to speak the result. And here is the history, how much analytics we have done, and how much issues are there. We can also train the module with the camera module. When we click on the tomato, we choose the our vegetable, and when we click on what disease, enter the disease in it, and when we click on capture, it will take the image from the pi, and the pi will use TensorFlow, and then it will transfer it to the web page. Then we can see the result. And so it
Hold
has
now.
the
Hold.
Yes,
What text-to-speech model are you using?
yes, sir.
Which TTS model are you using here?
Hello. Sir, I am using TensorFlow. So
I'm
I can
asking
show you the
for
code
the
also.
text-to-speech.
Yes, sir.
Okay. Second, what is the purpose of you using Raspberry Pi here?
Here I'm using Raspberry Pi because most of devices here that are presented web page and more of for India is currently offline, and most of the devices are currently more expensive. Using a Raspberry Pi device can and only in under 1000 rupees, and it can be used in and can used in the homes of people. And if that is used, it will be better, and
Your voice is
its
breaking.
accuracy will be
Please
more
check.
good.
Your voice is breaking. Please
Okay,
check.
ma'am.
Yeah,
I
please.
got it. I got it. I
Ma'am,
got it.
yes, ma'am. Yes, sir.
Dr. Bhumi?
Uh, yes, sir.
No question.
Hello.
Just heard the answers. Radha ma'am, there are no questions from my side.
Okay.
Okay,
So,
ma'am.
Shaurya, just let me know one thing. What is the
Yes,
size
sir.
of your model? I mean, what is the maximum size that Raspberry Pi would be able to take and run?
Role Raspberry Pi is here. It takes the images and then it uses the transfer for module light. Then it processes the image and then transfer it to the site. And it is a local host site where you can access the images, check the data of it, and it will tell us everything about what is it.
Okay. All right. Thank you so much.
Hello.
Thank you so much, teams. Judges, now it's time for your combined feedback for all the teams, and then we can close today's session.
We are looking forward to some very good work with the teams who are working on these problems. I see some very good use of foreign data mining tool again, but there is so much progress that the people can do with what the directions they are working in, especially when they are trying to mix up the vibe coding tools along with what they are presently working on. So absolutely great presentation. Thank you.
Ma'am?
Great work by all teams. I've observed that they have studied the concept. There's a clarity in the concept, and they have used the data sets properly. Orange workflow is nice. I mean, they have worked hard, but still, I think that there's a lot of scope of improvement in the presentation part also. But overall, the work is good.
Thank you so much to our judges, and congratulations to all the teams for your hard work, creativity, and dedication. This concludes our 1 hour presentation session. Have a wonderful evening. Thank you so much.
Thank you.
Thank you, ma'am.
Team, you can disconnect. Thank you.
Radha, may I take your permission to leave? Then I'll join back around 5. Is that okay?
Yeah, sure, ma'am. Sure, ma'am. Sure.
Okay,
It's
thank you so
okay.
much. Thank you.
Yeah, ma'am. Good evening, everyone. A warm welcome to the day 2 of OlympAI Hackathon Grand Final. Starting with the 11 and 12 category, we are excited to have all of you here today, and we truly appreciate the creativity and hard work shown by every team. This is a 1 hour showcase, and we will run on a tight schedule. Please note there will be no announcement during the session. We will close with a short feedback segment from the judges. Let's begin. Today, we are honored to have two distinguished experts as our judges. It is my pleasure to introduce them. Dr. Sachin Gupta, Dean, Research and Innovation, MAIT Delhi. Dr. Sachin Gupta brings over 21 years of experience in academia and professional world. He has held leadership roles such as Dean, HOD, and Director at various reputed institutions. His expertise lies in artificial intelligence and machine learning, and he guides scholars working on predictive ML model for engineering and business analytics. He contributes to national accreditation bodies including NBA, NAAC, and NIRF, and is a lifetime member of CSI and ISTE. Dr. Gupta has published extensively and authored multiple books on AI and data science for CBSE students. Recently, he was honored with an award for outstanding contribution to AI literature by AICRA. We are privileged to have him up with us today.
Best to all the teams.
Thank you, sir. Our next judge, Dr. Bhumi Gupta, Head Information Technology Engineering Department, MAIT Delhi. Dr. Bhumi Gupta has over 20 years of experience in engineering, education, research, and academic leadership. She heads the IT and Engineering Department at MAIT and is deeply involved in curriculum enhancement and faculty development. Her research interests include artificial intelligence, machine learning, and natural language processing. She guides PhD and postgraduate scholars and is a member of professional bodies such as CSI. Dr. Gupta has numerous national and international publications and frequently organizes academic events, including conferences, seminars, and FDPs. We are delighted to have her with us today.
Thank you so much, ma'am, for the invitation and all the best to dear students.
Thank you, ma'am. Before we begin, here are presentation guidelines. Each team gets 6.5 minutes total, 3 minutes for presentation and demo, 4 to 5 minutes for Q&A. Judges may interrupt briefly for clarification. Please ensure your microphone, camera, and screen sharing are ready before you turn. With that, let's proceed. We now begin the presentation for category 11 and 12. We have 7 teams presenting their innovative projects. Each team will get approximately 6 minutes to present, followed by a short question round by the judges. We now invite Team eSpirit to present. Your time starts now.
First of all, good evening, judges, and I am Anindra Dev Sharma from Narayana School, Raigad. So, so the problem statement is market and demand. Hello.
You're
Yes,
audible.
Anindya, please go ahead. You're audible.
So, the problem statement is market and demand movement classifier. In today's world, we can see that most of the people are going in the stock market or share market, but it's not easier to learn that. And I had gone through this problem. In this, I use as binary data through which it can just source either next day prediction will be up or low. So the targeted users are the beginners and the businessmen, means or any of the retail investors in today's generation. And second of all, what is the objective? Means what is the main aim? We can say that accelerating global investors to gain more capital, and I achieved it through building a binary classifier.
Brother, can we see the problem solution directly? We'll come to your presentations when we don't want to have any questions on this.
Yes, sir. Okay, sir. So wait a minute, it's not working. So can I go to the code? So sir, would you like to tell me input of any stock for processing? Sir?
You may choose your own.
Yes, sir, like Amazon, AMZN. So sir, it's processing now and I can go with the presentation.
Yes, please.
So sir, I use Python and the dataset I get from Yahoo Finance, that is Y Finance, and the workflow.
Please walk me through the code.
So code.
Where did the data come from? How did you process it?
Yes, sir. So this is the code.
I don't need to see the code. You can just explain.
So first I imported the modules, means like pandas and numpy and this all things, XGBoost and logging this all. And then sir, I imported light GVM and then the centralized settings with the data and data sets. So after that, I've this all the stock databases, and next of all, this is logging setup, and secondly, this input handling.
GVM and
Sir?
models used here.
Sir?
What are the light GVM and the GPM models used here?
Sir, I imported it.
What for? What is the purpose?
Sir, it can makes the program more better and it can make it faster.
Better and faster are very relative terms. I need to understand what was the specific purpose. Why did you want to use these libraries?
Sir, I don't have written knowledge on this, but it can make this program faster, means as it is, as it does too much of function. Therefore, to make the program faster, I use this. So can you proceed?
Which ML model are you using over here?
Ma'am, I'm using Python.
Okay. ML model, no? Python.
Yes, ma'am. After the data classes, and this is the data fetching area. And after that, this is advanced feature engineering, where means I have done all means.
Then how are you doing the predictions?
Yes, ma'am.
How are you carrying out the predictions?
Ma'am, it is I used XGBoost and ma'am, I used some modules for that, the pandas and XGBoost for it.
What is XGBoost?
Sir?
What is XGBoost?
So that is a means kind of model trainer. It trains the model, means it takes all the data, previous data, and sees when it means how what could be the outcome of the next day.
Okay, okay. Radhana, we can go ahead with the second team now.
Sure, ma'am. Thank you so much, team. You can stop presenting. We now invite Team Exin to present. Your time starts now. Team eSprit, please stop presenting. Team Exin.
Radha ma'am, I don't think they're here. Maybe we can move on to the next team.
Sure, sure, sir. So we now invite team Autocrates of Data to present.
Good evening, everyone. I am Neil Dolani from
Good
Airport
evening,
School.
everyone. And I'm
Good
Arya
evening. Please
Ramchandran from
proceed.
Airport School.
Yes, ma'am.
Okay. Hello.
Yes, you are audible.
Okay. So this is my code of the medical report summarizer. And here is the output of this code. Like we take any summary, any medical report, for example, this is of a 500 words. And if we take it and paste it here and click on the summarize button, it will take a few minutes, about 1 to 2 minutes, and then it will give the summary of the given medical report. And the features which we have added in this are like we can save it as a PDF, and in its improved version we have included a symptom checker and a feature which can include the voice input. And we are working on the see this is the summary of approx 3 to 4 words, and this includes all the main information which is given in the report.
We are heading for the future upgrades. Like in this, we can also save it as a PDF, and as we know, we can't transfer it to one another. So we are doing it.
Better please explain the method behind it, the algorithm behind summarization.
Sure, ma'am. Like in the code, we have used the library known as transformers, which is used to input T5 model. And in this code, the logic behind is that if we enter the report, it will read the report line by line and will convert and will understand the report, and then it will convert it to summary, which includes the main topic which are included in the report.
Are you using some LLM API in your project code?
Sorry, sir.
Are you using LLM API in your project code?
Yes, ma'am.
Which one?
Sir, your voice is not audible actually. Can you repeat the question?
Which LLM API are you using in your code? Which
Okay.
LLM API are you using in your code?
So, ma'am, we have used T5 small, which can convert the report into the small summary. Or if we want to use, we can use BART also, but BART is a very heavy library, so we have used T5 small.
Hi, Arya. Can you show me where you have
And
called this model?
can it be used for multi-language support, multiple languages?
No, ma'am, we have only done for English language because most of the medical reports are given in English language. But the improved version which we have made, we have installed a voice input which can convert the voice into text, and it can be of any language. Now we are working on it. It is half done and it's about to get done in 2 3 days.
So Arya, can I, Dr. Umi and Dr. Sachin, can I ask a question?
Yes, yes, please, please.
Hi Arya, can you show me
Hello, sir.
where you've called the inference T5 small?
Sir, here is the model name in the 19th line, model name T5, and in the output we can also see that at the where is my cursor, model T5 small ready.
No, I'm asking you in the code, in your
Yes, sir.
code, where have you called it?
Sir, just a second, I will see the code.
Right.
Sorry, sir, I'm unable to find it.
Can you quickly tell us how did you split the work amongst the three of you?
So, sir,
Sir,
I am Neil Dolani. So, my friend Jigar Ahuja is there for the coding purpose, and we interact with each other for some coding. And as we have used Tkinter, so we have some knowledge about among all of us. So we are using it, and by using some of the mentors' help, so we are able to make this program. And so we are discussing among all of us, so what we have to do, and all the choices we are giving among all of us three.
like sir, Jigar did the front end work and I did the back end work, and Neil helped us to like connect the summary will turn into PDF form.
All right. In your configuration, you've mentioned device is equal to -1.
Oh, yes, sir.
What does that mean?
So device is equal to -1 means that it will, like our mentors told us that this feature will not
Beta, who is mentor?
help the system to not get lagged.
Yes, are you
And
talking about
this
mentor?
also helps for the hugging face emoji transfers from the CPU mode. Like we are not able to use GPU because it is not working on our computer. So we have used CPU. That's why we have used the like device is equal to -1. If we were using GPU, then
Yes, Beta, who is your mentor?
Arpit Desai, he is our school teacher of CS.
Okay.
All right. Thank you, everyone. Thank you.
Thank you, sir.
Thank
Dr.
you, sir.
Sachin, over to you.
Sir, I just want to ask them, why did they select that specific model? Would it be good for any report summary, or for medical summary they need a specific model?
No, sir, we did not use it for just a medical summary. This can be used for many aspects, like if you have to summary of your any report or some PDF you have. So you can just copy and paste it in the summary, and it will give you the summary of that particular. But we are using it for the medical reports, as many of the people in India are not that much literate, and that's why we are using it for that.
All right, thank you so much.
Thank you,
Thank you,
sir.
sir.
Thank you so much, team. You can stop presenting. We now invite Team Aimers to present. You can switch on your camera and start presenting. Your time starts now.
Yes, sir. Good morning, sir. I am Mikrani from Team Immerse. We are solving the problem statement number 4.
Hi, Meet Kumar. Can you increase the volume
Yeah, yeah,
of your mic?
yeah. We are solving the problem statement number 4 market classifier. So, you can search any of the tickers. So, can you, Jamil, please write any of the share name with .ns for Indian shares.
But can it be little more audible? I'm not able to hear anything.
Yeah, so we are solving problem statement number 4. Can Jamin you write any share name? So it is based on XGBoost binary classification. The ML model we have used follows random tree because XGBoost is made on random tree, and the random tree learns from its previous mistakes. And API here uses of Y Finance, Yahoo Finance, and we get the retrieve the API from here. Can you, Jamin, also see open charts? So live data is retrieved from there. This is the 5-year chart of Adani Green. Can you? So it here comes the confusion matrix, which is the main matrix in AI training model. There are two actual values and two predicted values to find out how much accuracy we have got. The accuracy we have got is around 65 to 70%, and it is the ROC. Jamin, can you go? It is an ROC curve. It is also same for the metric. The threshold we have made for it is around 0.5, which is a almost certain threshold most of the time. So, and we have you. It is the returns distribution daily frequency. You can
Abhinav,
see
can
the
you go back to the ROC slide?
yeah.
How can you explain how good is the model based on the ROC?
Yeah, we I can also show you the PDF if you permit. Jamin, can you please?
Just by looking at the diagram.
Yeah. So as it is the linear progression ROC as it is increasing, so we have set it 0.5, and you see this straight line as the model is around this line. So it there are two rates. One is true positive rate and one is false positive rate. More the ROC curve near to the 0.5, it shows how good it is. The third feature, it is scenario lab. As we know that AI can't replace humans, so we have made this where a user or a trader can adjust according to him. We also got live news feed from Google API. If we search about company, we got live financial news about it, and we can go and check about it the same. And we have one PDF of
Okay,
correct
but
prediction.
yeah, just wait. And what is the good value for the AUC?
Sorry.
What is the good value for AUC?
It's around 0.375 or around between 5, from 0.3 to 5, 0.5. 0.5 is taken as the median threshold frequency because of its.
Okay, okay.
Can you, Jamin, open that correct predictions PDF also so we can show them? Yeah. So you can also see the small letters. There is a date and time also. We have not made it the stock predictor. It is the stock classifier. It shows whether price will go up and down, but in several cases we have gotten exact same values. So here is Adani Green, and it is gone down. Can you go behind it also? Can you see us other share?
Which data are you using? Where are you picking up the data from?
We are picking it from Yahoo Finance. Last 5 years data. First we try for 2 years data in PPT, although we have submitted of 2 years, but the accuracy we want was not exact, so we converted it to 5 years data, and then model is trained according to it.
Okay.
We can also show. Jamin, could you go? As it is target is 52.55, and the negative prediction, can you go beside, is around 2.59, and in 70 of the cases we have gotten it right. And like it is working on both and Indian stock exchange and foreign stock exchange, both of them.
Okay, hold
Yeah.
and hear me out.
Yeah.
You have a very good interface. Okay.
Yeah.
You have got a very good reporting also. But your model baseline says we are 50% confident. That means it's saying as if it's a heads and tails thing. That it might be correct, it might be wrong, and we are 50% sure about it. Do you get me? That is what the AUC value is suggesting.
Yeah.
Okay.
So let me counter this. It is not same on every charts. Like there is the stock market has very noisy and it is undiscreted data. So AUC is almost different for every chart. We made it user able can see that every chart we have made, and it is different for every different share. We can also try any such as for Nvidia. We can also try the same. Could we?
Actually, the confidence here, the current prediction of Adani in NS, the confidence is 83.4%. So, like, it is what model thinks, like, using the data set, what he thought, what the model thought.
AUC
The
keeps on
current confidence is, I think.
and AUC keeps on varying according to the share we are using, because most of time share market is very noisy and discreted, so we can't get always right. It is like humanly impossible for any model to do this. We have used indicators for it such as Ikimago cloud to get where the price will go up and down, such as SMA, simple moving average, MACD, and we have also used
Uh,
that.
Radha ma'am, can we move to the next one? I suppose the time is out for this.
Yeah, sure, ma'am. Thank you so much, team. Now we invite Team Think Tank to present.
Thank you.
You can switch on your camera, start presenting. Your time starts now.
Good morning, everyone. In the next 15 minutes while I speak, more than a dozen drivers in India will drift into microsleep, and for some of them, that 1 second of fatigue will become a lifetime of loss for their families. Drowsy driving isn't just a bad habit, it's a public health crisis hiding in plain sight. So, our team asked a simple question: what if a vehicle could sense fatigue before the driver even realizes it and prevent the accident entirely? Today, we present our answer. And I'm Mayank, and alongside presenting with me are Srihari and Vivek Jacob.
This is our AI solution NeuroDrive. It watches subtle cues such as the eyes, the mouth, even the duration of a yawn, and reacts
Could
instantly.
please
And we built
go
a working
straight to
model
the demo?
around a Raspberry.
Yeah, please go straight to the demo, the project.
Yes, ma'am.
Okay, so ma'am, so basically we have our software side and we have our hardware side as well. We have done a hardware integration. First, let me just show you the software side. So we have used, let me just explain why did we used each library. So CV2 is obviously for OpenCV, so we can like track the camera. Then time is just for we have used an alarm module, which is like alerting the driver. So the time is just to keep the time of the alarm. Then threading is so that none of the pipelines get interfered. NumPy we have used because we want to store the values of the array. So we have used the library MediaPipe. So MediaPipe is it has many landmarks for the face. It has around 468 landmarks. So we've used MediaPipe, and to store the arrays we have used NumPy. And SciPy is to calculate the Euclidean distance so that we can know calculate the eye aspect ratio and mount aspect ratio. So let me just jump straight into the demonstration. So I hope we can see my screen. So as you can see here, this is in the system. It's like live every frame. It's actually calculating my EAR and MAR values. So here, suppose I close my eyes. Um as you can see, as soon as I close my eyes, the EAR value is increasing. So we have set a threshold of 0.21. So as soon as the EAR value crosses the threshold, the score increases, and as soon as the score goes beyond 100, the alarm starts ringing. So and now for the now EAR. So basically, when a person is sleeping, there are we have taken two aspects of it. One is obviously the eye closing. So the eye closing, it's pretty obvious to understand, but the tricky part is when the mouth, like the MAR value. So for example, as you can see, I'm speaking right now, and then it shows green, right? So that the reason because of that is we are not just calculating the MAR value. We have actually made like our own what do you say like machine learning model which classifies images into two data sets right now, which is yawn and no yawn. So for
And
example, if I open my mouth right now,
the other team members' contribution, where are they?
ma'am, and like they will talk about the hardware side and just like doing the demo of the code.
Okay.
Since yeah, so if I open my mouth here, as soon as I open my mouth, if the MAR value goes beyond something, so beyond the value like 0.4, the image of the like the it takes the specific part of the mouth and then sends it to the machine learning model. So the machine learning model will classify it if it's yawn or no yawn, and as soon as you can see, it's giving me a warning. It's also giving me like alarm, so the driver is alerted as soon as he suppose if he's sleeping, and it's also counting the yawn and also long yawn. So suppose if the long yawn, if the driver is continuously yawning for say more than 3 seconds, 4 seconds, that means the driver is extremely sleepy. And suppose if it's more than 3, 4 yawns, we start giving like a perpetual continuous alarm.
Can you move on to the hardware part?
Yeah.
Explain.
Yes, ma'am. So as you can see here, this is a robot which we have built. Vivek, can you just explain?
Yeah, so all of this contributes to a single elegant metric, a drowsiness score from 0 to 200, which rise and fall smoothly according to the behavior of the driver. And then, as you can see, the robot, it responds to a low score, which translates then to a normal speed, a medium score to a slowdown and waggle to wake up the user up and turns on the hazard lights. So it also allows the nearby vehicles, which then tells them that there's something wrong. And the high score or the long yawns, they translate to complete stop. So this model is very predictive and
And
effective at the same
what
time.
are you using for the processing?
Ma'am, we made our own TensorFlow model. We have used Google's teachable machine, and like we have made our own TensorFlow model, and that's doing the classification for this, and the processing, all of it is done using this Python code.
And what is the computational requirement for this?
Ma'am, the thing is, computational requirement, ma'am, like if I heard you right. It's basically right now it's using a simple machine learning model. So like right now we have used a Raspberry Pi 5 to run the machine learning model. Let me just close this. Yes, right now we have used a Raspberry Pi 5. It has like
What is the cost of all of this, the total project?
ma'am, I would say yeah.
Now, speaking about the cost, so we would usually sell this at 12,000 rupees. But talking about R&D for the development of this AI module, we would spend around $10,000 to make this commercially safe and like perfectly all right for to be used in many vehicles.
I'm not
But
talking about the sale value. I'm asking about what have you spent on this?
Oh, okay, ma'am. So like the Raspberry Pi 5, it was like my birthday gift. So it was around like 10,000 rupees for the Raspberry Pi 5, and the car module was around, I would say, 2,000.
Okay.
And I'm speaking about it's like all the contributions it would do. 30% of fatal accidents in India are caused by driver drowsiness. So we aim to in using these models, we will we projected a result, and we would see that 82% of accidents would be potentially reduced, and using a 96% accuracy. In addition to that, we also took a survey, and we received considerable amount of responses to build on our future scope plans, in addition to the points that were listed in our PPT. And this way, we also were able to alter our project accordingly to the struggles and needs of the drivers who think that driver drowsiness inventions like these are essential to keep drivers safe in road accidents.
Sorry, I just got disconnected.
And ma'am, lastly, we would also integrate this with steering, vibration, CAN bus controls, personalized calibration and fleet dashboards. It's a small system, but with a huge potential to make an even more bigger difference. And we would like to conclude this presentation. Thank you.
Thank you, ma'am. Thank you, sir.
Thank you, sir.
Thank you, sir.
So, any questions?
Judges, any questions? Bhumi ma'am, Sachin sir.
Yeah, I think we can move ahead. Dr. Bhumi?
Nada ma'am just got out of the network. Sorry, but we can move forward with the next team.
Okay. Thank you so much, ma'am. Thank you so much, team. You can stop presenting now. We now invite Team Realty Devs to present. You can switch on your camera and start presenting. Your time starts now.
Good evening, judges. I am Rudransh Singh from Reality Devs. I'm the only member, so I will quickly show you the demo of my product.
Rudransh, please switch on your camera.
I am not able to turn on my camera because it is not working. But I got the permission from Ashish sir to continue without the camera.
Okay, fine.
All right. So I will first quickly show you the demo, and then we will see the code. All right. Let's move to the code only. Ma'am, can you give me 2 more minutes? I've joined from phone, so it's not. I can't show the demo.
Okay, let's move to the next team. You can prepare.
Yeah, I'm joining from my PC right now.
Okay, no problem. So we now invite Team Neural Knights to present. You can switch on your camera and start presenting.
Please present at the end.
Team, we are not able to hear you. Please move straight to the project. We can skip the presentation for now. Team, are you there?
Ready to help. Can you hear me, ma'am?
Yes, you are audible.
Can you?
Please proceed. Judges, I think we can move to Team Exxon.
Yes, ma'am. Please go ahead.
Okay, Team Exxon, are you there?
We need a little bit more time.
So, if
Hello, ma'am. Can you hear me now?
Yes, you are audible. But we
Right.
can't see your screen.
Okay, Neural Knights, you may present now.
So I'll show the demo of my project first.
Yes, you're audible.
So this is my demo, which is run by manual coding. And I have used Anaconda prompter, which is an Python-based prompter. So I have preloaded the codes beforehand. We have created an environment in this prompter, and we have installed OpenCV, PyGames, PyTTSX for text input and voice module, and NumPy for number calculations and presenting of numbers, and MediaPy for case detection modules. So I have stored my file on C drive so it could access the files easily. So this is a module running. If I close my eyes, it will show drowsy and an alarm will be. Once it stops when it finds the eyes are open, and if my mouth opens and amount of maximum amount or more than an average amount like this, it detects that I am drowsy and it alarms me so that I should wake up. And it has an head drop detection also. When the driver falls asleep like this, so they can detect and make the time. So this is an developing state. We would like to develop it more and much better in the future with modules like Pi and other modules. So we could do it for the car modules. It can be made within 1 month or 2 month time. So we have made a PPT regarding this. So this PPT shows what that model does. Thus, this model shows that approximately 20% of accidents are caused by sleeping by driving. It may help us improve the rates of accident prevention and more. This AI-based tracking model is done based full and fully on Python, and it's run on Anaconda prompter. So the objective is monitoring and sending alert messages locally to the driver, so the driver can wake up and be safe. The overview of system says it calculates the head position, face landmark, AR and MAR to analyze and give real-time alerts to the driver and signal the driver how they are sleeping or they may feel sleepy. This uses media by face mask accurate facial landmarks so that it can detect human face and it can be give outputs to the device. OpenCV is used to take camera input from the device, and AR and MAR logics are implemented into that so that it can detect eye aspect ratio and mouth aspect ratio so that it can send messages if the eyes are closing or the driver is yawning. The video input is getting from the laptop camera.
Sachin sir, Bhumi ma'am, any questions?
Yeah, I'm just looking at the project. Can you
Okay,
tell
sir.
me which particular libraries have you used for inference? MediaPipe is one.
NumPy CV2, sir. Time and Pi games.
Okay.
What is the use of Pygame in their project?
So it is used for alerting sound implementation, sir.
Okay.
So that
Can you
it gives an alarm sound.
and can you show me the code where you implemented EAR?
Sir, here's the mesh, media pipe mesh, face mesh. So if it gets the values here and calculates the AR MAR ratio here.
And what? How did you decide on the threshold values?
We have gone testing with that and we have decided that.
Can you elaborate more on the testing? What kind of testing did you do?
We have checked that thresholds on various 2-3 peoples and found a sweet spot and kept them.
Right. Dr. Mumi, Dr. Sachin, do you have more questions?
Would it be different for different people? I mean, I understand the part which you are saying that ER threshold, MAR threshold, they are values, these are good for you. Somebody having small eyes or somebody having small neck size, would the values be different for them or would the values be same?
Yes, sir. We can differentiate between small and peoples.
You can. I mean, how do you think would it differ? Would your model still work on everybody in general, or it has to be changed from person to person?
It works on everybody in general, sir.
With the same threshold?
Yes, sir.
Okay.
Any other questions?
Sure. Thank you.
Thank you, sir.
Thank you so much, team. We now invite Team Exxon to present. Are you ready? Team Exxon. Team Exxon, are you ready?
Yes, ma'am, I'll present.
Yes, please start presenting. Share your screen and switch on your camera.
Ma'am, I have asked sir if I could switch it off because I don't have a camera on built-in camera in my PC.
Okay, no problem. Please proceed.
Ma'am, this is the code. And ma'am, we have used the model BART because it has a large language library and yeah, we have used BART and it also has a multilingual feature. And it runs like this. I've already opened it. And it also has like you can like check the minimum level and maximum length, like how big you want the report to come out. And once you can take um a sample paragraph and you can generate a summary.
Where are you getting your models from? I mean, BART or somewhere, whatever
BART.
model that you are using.
It's BART.
Where are you using it from in your code?
We're using it here from Streamlit.
I mean, is it through an API? Are you
No,
importing it?
we're not using API, but we imported it. Yes.
Where did you
imported
download the model
from the Python
Here it's
interpreter.
from the transformers package in Python. It's available there. We imported it.
Yes, so the summary comes out like this, and it also shows how much it reduced the words and the grade level, like what kind of person can read this summary. and like the readability score, and it also shows detail and analytics and like the reading level. And you can also download the report over here. And it also supports the UN sustainable development goals, and then it supports vulnerable populations, so people with a lower literacy rate can easily use this website to generate a summary which is easy for them to read and they understand. So it has a role in supporting communities worldwide which do not have much of a literacy rate. Yes. And we can also like use these advanced controls to increase the length of the summary or even decrease it. And we can also like we can actually like post any medical report over here, and we will get like a patient friendly summary which people actually will understand. And we also have we plan to make this code more better by adding a multilingual feature. Now we're using a basic English language BART model, but then we want to make this better by using like importing another API to make it better, like add multi-language or use the multilingual BART model to make it better. Yeah.
Can you tell me a little bit about BERT? What is the purpose of BERT? And why do you choose it over any other model?
We chose BART mostly because for it's great at summarization, and that's mostly what we needed it for.
But why
And sir,
BERT?
it's one of the most reliable open sources summarization models available, and you could trust its meaning and all the medical accuracy that it was providing. So.
It also was
I,
self-hosted.
Shweta, if Shita, your code, when I saw the screenshot for your code, if you can open it again, there are three VENV folders on the top.
Sir,
Can
we
you open the
sent the
code
code
window
also.
again?
please share your code.
We sent the entire code.
Yeah. On the top, there are three VENV folders. .venv, .venv1, .venv2. What is the purpose of all three these?
Sir,
Yeah, hi.
it comes from the bits and bytes library, which is there in the. It's because it's a large model, so it's a tool used for model quantization and even for reducing memory usage, because it's a large model and we are trying to execute it for making it a public website. And it even speeds up inference, especially on the CPUs or even small GPUs.
Did you get my question correct? I asked you, why do you have three VENV folders in your project?
Sir, we didn't quite get your question. Like where?
On the left side of your Python project, in your folder directory, in your directory. Yeah, here in your directory on the left, you'll have three folders which show VENV1, VENV2. What are the Dr. Sachin is asking you, what is the purpose of these folders?
No worries. Can you tell me what is the uh, contribution of each individual in your project?
Okay, so mostly Swara designed the did most of the coding work, and my name's Ipsita. I did most of the UI design work to make sure that the website was more accessible.
and then the presentation part was done by Tapasya.
Okay, thank you. Thank you so much.
Thank you.
Thank you.
Bhumi ma'am, any questions?
Anuradha ma'am, there's no question. Nothing.
Okay. Thank you so much, ma'am. Thank you, team. You can stop presenting now. We now invite Team Realty Devs to present. You can start screen sharing and switch on your camera, team.
Yeah, ma'am, I took permission from Ashish sir to turn off my camera, and
Okay.
now I will be sharing my screen. So first,
Yeah.
let me show you the demo.
Please proceed.
Yeah.
Can we leave the meeting?
Yeah, sure, if you wish to.
Is my demo visible? Demo video?
We can only see the folder.
All right, just a minute. Yeah, now it will be visible, I guess. Yeah, so this is the demo. I don't think you will be hearing the sound right now because I don't have a microphone attached to it.
Can you
But
not
it,
show your project running? We've seen the video already.
yeah, because I don't have a webcam attached to my PC right now.
Can you show your code, please?
Yeah, sure. Yeah. So here's my code. Our system works in 3 steps, which is capture, detect, and analyze. In capture, we take a live video feed at 30 plus FPS. Then we use DLIP's 68-point landmark library, detector library to map the face. And then we focus on the eye aspect ratio, which you can see here, eye aspect ratio. Let me tell you what the code does line step by step. So first, as you can see, these are setups and imports. CP for distant math, DLib for face detection, CV for image processing, and Pygame for sound. All right, then I have this is constant tuning, which is um, yeah, just a minute. Yeah, so this is the constant tuning. Basically, the maths. It is simple but robust. When your eyes are open, the ratio is stable. When you blink, it dips briefly. But if the ratio stays below 0.3 for 50 consecutive frames, that is about like 2 seconds, the system will know it's not a blink and it's a microscope. And then it will trigger the alarm instantly.
Okay, why are you using this XML file in your code?
Which one? XML?
There is an XML file here.
Yeah, it's this one is a backup. These both. So I have used DLibs library for this project, but I have also used Har Cascade library. This is also a library, but it was for backup. My main library, which I have used in this project, is DLibs.
That is imported through which specific?
Uh, can you repeat?
Can you show us how it's imported and how it's when do you call it?
Yeah, sure. Just a minute. So first, let me check the code. So first it load the face detector and predictor. This is where I called it, and then it does the work, and then I've used some maths function in order to make the DLib library work.
So your program is basically taking both the libraries at the same time.
No, it
Cascade
is
also.
only taking the DLib library, and if by chance the DLib library won't work, then I will think of using the second library. But it is not automatic right now. I just use it for backup and then forgot to remove it. Now I would like to show. So this is now I will tell you what improvements can be made in this. So firstly,
Team, sorry to interrupt, but we already ran out of time. It's already 6 now. Judges, if you have any question, or else we can.
I just want to ask them one thing. Why have you chosen Euclidean distance here?
sir, can you repeat again what I?
Why have you chosen the Euclidean distance as a metric here?
Euclidean.
You've used Euclidean
Could have
distance
been
to
cosine,
measure
it
eye
could have
aspect
been
ratio.
Oh, so which is here, Euclidean distance is used in the eye aspect ratio because it provides the straight line distance between, the facial landmark and 2D image plane, which is most accurate measure for eye openness. So
Got it. Thank you.
I basically focused on the eye occlusion, not the yawn detection one. And to be honest, this model is perfect example for me as I have exams going on. So I constantly use this model to wake up, to keep studying in night. So if I fall asleep, this like triggers the alarm and then I wake up.
Okay, that's nice. Okay,
Bhumi
thank you so
ma'am?
much.
Thank you, sir. Yeah.
No, Radha ma'am, there is no question. I was listening. Oh.
Okay, thank you all teams for your presentations. Judges can share their consolidated feedback and overall observation.
Okay, good job with the problem statements they were given. Some different type of approaches, some had the similar approaches. We'll take into account. Mostly the judgment would be based on how far they would be able to answer the questions that we asked. So because some projects were similar. So, but I mean, commendable job by the students. Thank you so much for your presentation.
I have a
Good
doubt.
job. Yeah, what is the doubt?
No, I'm just curious to. I want to connect with the judge to collaborate on future projects or get something in advice. So can you put the
Yeah,
socials
do
of?
not worry. Message I will let you connect. That is not a worry. We'll connect you.
All right.
Sir,
Yeah.
can we try again to present because time has exceeded our presentation in between? Can we
I'm
repeat
sorry,
it?
we're done with time, so we would have to end this presentation now. Thank you so much, everyone, and Radha ma'am. Can
Yeah,
end.
sure, sir. Thank you so much to our judges and congratulations to all teams for your hard work, creativity, and dedication. This concludes our 1 hour presentation session. Have a wonderful evening. Thank you so much.
Thank you, sir. Thank you, ma'am. And all the best to the team and
Thank you,
students.
judges.
Thank you.